Hi, let's see how to implement central limit theorem in R. Central limit theorem is an important concept in statistics and data science for any further analysis. So it says, regardless of the original population distribution, the distribution of the sample means will approximate a normal distribution as the sample size increases. Now we'll see how this works out in practice. Let's start with creating a population, generating a population of non-normal distribution with a non-normal distribution. We'll set seed. This ensures the reproducibility of the population that we are going to generate. To run the code in R, you can click Ctrl plus Enter. Now generate population will take exponential distribution of, let's say, samples size of 10,000 and mean of 2. This means this creates exponential distribution with mean 2. Mean is equal to 2, that is 1 by rate. Let's run this code. Now our population is generated. We'll see the visualization of this population, how this distribution is. We'll create a histogram of population with bin size 50, color of, let's give sky blue, title population distribution. We know exponential, so let's give exponential, and X label value and Y label frequency. Let's run this code and see how our population distribution is. Yeah, now see, this distribution is skewed, so this is not a normal distribution, and it's a perfect example to demonstrate the central limit theorem, how the sample drawn from a non-normal distribution approximate a normal distribution. For this, let's create a sample demonstration of central limit theorem. Now let's create sample size, different sample sizes. For example, we'll create sample sizes of 5, 30 and 100. This creates different sample sizes. Now we'll create a plot grid. This creates a plot grid of 2 by 2. For size in sample sizes, well, here we are generating sample means. Sample means 1000 mean sample population size. So what this does is it creates a it replicates for a sample size of 5. It creates 1000 sets of sample sizes of 5. Similarly, for a sample size of 30, it creates 1000 sets of sample sizes of 30, and similarly 1000 sets of sample size of 100 from the uh, it from the population that we generated, and it creates the mean of each of the set of sample mean of sample size of 5. Like that, we'll have 1000 means for sample size of 5, and 1000 means for sample size of 30, and 1000 means for sample sizes of 100. Why we are doing it is, the theorem says the distribution of sample means, not the sample sizes, the distribution of the sample means, and not just one sample mean. So we are creating 1000 such means for each different sample size. You can do it like 10 such means, or 100, or 200. Any number would be fine, but one would not make any sense. Now we'll create a histogram of these sample means. Plot the histogram of sample means. Hist sample means breaks bins color. Let's give light coral. Main is titled sample size is equal to size x lab sample mean y lab frequency. Now we'll give a title for this, a whole plot layout. Demonstrating the central limit theorem. So we have 3 margin outer gives count. Now let's run this and see how our the distributions of sample means of different sample sizes we created from the population distribution. Let's run this. Now we have distributions of sample means of sample sizes of 5, 30, and 100 that we have drawn randomly from our exponential distribution. So this is the exponential population distribution, and these are the distributions of the sample means we have drawn from that exponential distribution. For a sample size of 5, the mean distribution of means is this is skewed. However, this is approximate becoming a bell curve, sort of bell curve. So, and if we increase it to 30, it approximated normal, a bell curve, and this 100 is a bit better than this 5 and 30. So from here we can say that uh, we are we implemented the central limit theorem R. That is, when you draw a random sample size from any distribution, and if the sample is large enough, the distribution of sample means would approximate normal distribution. So hope it is clear. Thank you.